We're looking at the master test frame of a Western Electric number 3 crossbar switching system. This is one of 2 remaining crossbar switches, model number 3 that is, that's left in the United States. Western Electric only manufactured 28 of these systems, and this was assembled on a metal frame, wired and tested at the factory, and then trucked to the site that it was going to be serving, the community that it was going to be serving. I have purchased this from Nevada Bell and then relocated it to Oregon, and unfortunately we did not have the ability to move it as one piece, so we had to disassemble the switch and then move it and reassemble it. This has been a very labor-intensive operation to do. At this point, the flashing lights on the master test frame indicates that I have equipment that is temporarily out of service, made busy. The master test frame had the ability to set up calls, monitor calls, and record troubles, such as if there was a failed marker or a register and so forth. It would light up different lights telling you what had failed. It also has the ability to test the trunks locally or make them busy. This was a very sophisticated system for its size. The number 3 crossbar was initially designed as an 800 line machine, and then after 4 or 5 was built, they went back and expanded some of the trunk link frames to allow another 400 lines. Number 3 crossbar being a 1200 line office, 80% of the bays of equipment is common equipment or trunks. So the amount of lines that this would serve took up a relatively small amount of relay rack space in comparison to all of the other auxiliary equipment required to make a crossbar switch work. The number 3 crossbar system's markers are what is referred to as combination markers, which means that they can set up a call for dial tone or complete a call within the system, or set up the proper information needed to complete the call outside of the system. In a normal number 5 crossbar situation, you would have a dial tone marker, and its only function was to provide dial tone or establish the connection for the dial tone, or a completing marker that would complete the call. The number 3, because it was a small office, they had 2 markers so they could do either function. Normally, marker 0, for example, would, when a customer went off hook, would set up a call to give dial tone out of an originating register, and then marker 1 would complete the call when the customer was finished dialing. Of course, either marker can, like I said, either set up a call or complete a call. And if one is made busy, then of course it does both functions. When a subscriber requests dial tone, they go off hook. There's a line relay, of course, like in a step-by-step system. The line equipment requests that the marker complete a call, or set up a call, I should say, to what's called an originating register. The originating register is what provides the dial tone towards the calling subscriber, it records the digits that they have dialed in either touch tone or dial pulse. And at the end of 7 or 10 digits, then the register requests that the marker come in and look at the information and then act on it accordingly. If a call was to be a local call, the marker would then, of course, would ground a code point to indicate that it's a local call, and then it would set up the call within the system on what is called an IAO trunk, and then the customer and the called party would be talking on the IAO. If you was to dial a 1 or a 0, then you would put in the additional information for long distance calls of the operator, and then the register has a couple extra relays to deal with the 1 or 0. And then, of course, at the end of the 7 or 10 digits, it would again request that the marker would come in and look at the information and then act on it accordingly. In this particular system, I have 6 of these originating registers, which means we can have 6 people receiving dial tone and dialing at the same exact time. Of course, this is only for the originating part of the call. If there was a call that was coming into the system, we would be using an incoming register, which will be discussed further on in the video. Alright, in my particular number 3 crossbar system, I have 400 lines. This machine again was initially designed to be 800 lines. Then it was expanded, or the capabilities was to expand it to 1200 lines. In the office that I bought, it was only equipped as a 400 line office. This number 3 crossbar, and all number 3 crossbars, used what was called CF type crossbar switches. These are a mini crossbar switch. More high density is what the reason for it was. So again, in this particular machine we have line relays, cutoff relays, and lockout relays. In a number 5 crossbar you would not have 3 relays for each line. They would have a line relay, and then the cutoff function was done up on the crossbar switch itself. The number 3 crossbar was designed as a little office, so they didn't need to necessarily reduce the amount of equipment like in a number 5 due to the size of it. And there is a certain amount of economics involved in making a number 3 versus a number 5. And again, this is a 400 line machine. So every single call that is made, the crossbar switches would operate on, either to set up to an originating register, to get you to an intercom trunk, which is referred to as an IAO, or an incoming trunk call. At this point, we're looking at the marker connector relays. These are 30 contact relays. The function for these is when a piece of equipment requests that the marker provide some type of a function, either to complete a call or to give dial tone, you operate certain marker connector relays, which then connects a massive amount of leads between the originating equipment and the marker. Some of these, we may operate 6 or 7 of these relays in one shot in order to provide enough leads to the marker to determine the type of a call and what to do with the call, what it's originating from or terminating from. One thing is, when these relays operate, this is one of the things that draws a tremendous amount of amp load in addition to the marker. One thing about the number 3 crossbar, in my idling state right now, we're drawing about 10 amps of DC power. In order to give dial tone for one customer, it takes about 12 amps for 1 second in order to establish a connection between the line circuit and the originating register. Once the information has been dialed into the originating register, it takes approximately another 12 or so amps for the marker to complete the call either within the switch or externally. These are the IAOs. These are effectively an intercom, of course, for the number 3 crossbar. So the originating customer would be on one side of the trunk and the terminating customer would be on the other side. These were only used during an intra-system call. Calls outside of the system would be on a trunk. Incoming calls to the system was on a trunk. So there's a limited number of IAOs. Because it's a 400 line office, they didn't anticipate that many telephone calls. I have, I believe, 30 of them, which of course means you would have 30 local calls at any one given time. These are the incoming and outgoing trunks that was used in the number 3 machine. The original design of the trunks that I have was all E and M type trunking. Thanks to Mr. Steve Flocky, retired engineer, he rebuilt from a circuit standpoint the incoming and the outgoing trunks, drew up a new schematic, and then we actually modified them so that this system could talk to a step-by-step system, either outgoing or incoming. In addition to, I do have some of these that are still E&M connected to the Asterisk system, which then of course is on CNET. And the CNET code for the number 3 crossbar is 543. And I have about 40 of the trunks, 22 to 24 I believe incoming, and then the remaining outgoing to either the step, X, Y, or other switching systems. The nice thing about the number 3 crossbar is these trunks have an Amphenol connector on the back of them, and you can physically remove one strip to rewire or do maintenance on, modify, and so forth. In a normal crossbar machine, everything was all hardwired, and you had to repair it in the bay where it was actually at. So that was one of the nice features that they had come up with on the number 3 machine. Here is the junctor switches within the number 3 crossbar. Every single call, internal or external, either incoming or outgoing, is completed through these. There are 9 of them in this bay, but we're only showing 3 at this point. This is basically the gateway for every trunk, register, and so forth in the office. So these crossbar switches get the maximum usage of traffic versus some of the other switches, because every call has to go in or out or through them. That is, when you request dial tone, the marker completes the path from the line equipment through the junctures to the registers, and of course when you make a call within the system, then we have to switch it to an intercom to IAOs, or if you made a call outside the system, then it has to land on a trunk and then complete the call externally of the system. There is also additional crossbar switches brought into play when a call is being made outside of the system, because we have what is called senders, and senders of course will either send MF or DP depending on the office that it is dialing into. And so we have what is called an outgoing sender link frame, and we have also an incoming register link. They're all identical looking crossbar switches. So once you've seen kind of one switch, they're all identical. They just are wired for different functions, and they are located in the switching system in different relay racks. I've included on this a shot of the operator trunks. One thing's kind of interesting is every trunk in the system is a single mounting plate of relays except for the operator. The operator of course had the ability to collect and return coins and pay phones, as well as ring the phone back, and there was other functions that the operator could do, and so they ended up using 2 relay plates. So we have in this office several of these operator trunks, but these take up more real estate than the singles, and of course these were probably the least revenue producing of any particular item in the office. We're looking at the ballast lamps in the number 3 crossbar. This system has a lot of ballast lamps in it. Each ballast lamp is in series with either the dial tone, the busy tone, or the ringing within the office. And under normal circumstances, the ballast lamp should never light up. If there was an excessive load or a short, the light would light up, and then I would have to refer to a page in the documentation of the office to tell me what each individual lamp is wired to, and then go to that piece of equipment and try to clear the trouble. So there's a lot of ballast lamps, and they do look like light bulbs, but they're not intended to light up. So it's a good thing to see them not lit up. These Type 70 fuses are in the circuit between a, let's say for an example, a dial tone source and a register or a trunk. Unlike in a step-by-step system where the tones are connected from a grounded transformer with one lead to ground and one lead to the equipment with tones superimposed on it, in the crossbar system they superimpose the tone onto the negative 48 volt battery system. The reason for that was if a trunk or auxiliary piece of equipment such as an originating register was to develop problem, it would blow the Type 70 fuse, and then it would isolate that piece of equipment from the rest of the tone source in the office. In a step-by-step, if you was to ground the dial tone lead at a first selector shelf, you would affect most of the central office for at least the dial tone segment of the plant, ringing plant. Here, you would only, in the crossbar system, you would only operate a fuse. This was a pretty neat idea. One of the things that was an education for me is because I'm running this entire crossbar switch off of my Western step plant, is I had to build some circuits to interface the crossbar to the step and to invert the ground source into a battery source. So these particular fuses we're looking at would have busy tone, dial tone, or reorder tone superimposed on top of a 48 volt source. If a piece of equipment was to develop a trouble and blow a fuse, it would light up its associated light, letting the craft people know that there was a issue in the office. And every single fuse is recorded on a chart, so whatever fuse was to blow, you'd have to find out what it was wired to and clear the trouble at that piece of equipment. These are the slave relays that's working off of the motor interrupter in the central office. We have the 60 and 120 IPM, so we have the 120 here and the 60 here. These relays are opening and closing leads and also interrupting a continuous tone to provide a busy or reorder tone. And there's also timing stuff in the office that needs a pulse for like a charge condition on an answered call if it was a message rate circuit, which this office does have the ability to do message rate service, and so we would be using pulses for that. The number 3 crossbar, like the 5 crossbar, has what's called a local number translator. The function of a local number translator is to take the directory number, or the telephone number, and convert it to line equipment. In a crossbar system, the telephone number does not directly correspond to a line equipment number. It has to be associated. So you can have any telephone number wired within reason to any line equipment number. Also, for outgoing calls, such as toll calls, the system also has to have line equipment number to directory number so that it can put that information into the sender and then send it off to the toll office. So the LNT does 2 functions. So internal calls or external calls into the office, they look for the phone number to what equipment it's wired to, and then on originating calls from the crossbar to the world, then it looks at the line equipment number to determine the phone number. There are two LNTs in this particular office. Each LNT's got 300 phone numbers on it, at least in the number 3 crossbar. So I have 400 lines, but I have a total of 600 numbers. So the number 3 crossbar was originally designed for 2-party service or 4-party service. So someday I may try to wire up a multi-party phone line in the office. Where this was installed, they did not use any of the multi-party features. This is the incoming register. A normal number 5 crossbar would have a larger incoming register, which would have more relays for digits incoming, because in like a number 5 crossbar you would have up to 10,000 telephone numbers. The number 3 crossbar system, since it's only got up to 1,200 numbers, we're only using a very small percentage of a prefix. So this was designed to be a 5-digit or a 4-digit register for incoming calls. Now this register has the ability to receive dial pulse, or wired in conjunction with it is a multi-frequency receiver. On an incoming call, it is only going to look for 4 to 5 digits. If I was in my step-by-step system calling into this, then of course I would be sending 4 digits. The number 3 machine originally was wired with 2 office codes. So it was a 20,000 telephone number switch, but it only had the ability to handle 400 actual telephone numbers. From what I read in the wiring information, is Nevada Bell had some stations connected off of this machine that was along highways or mountaintops, and they wanted it to have a different prefix for billing reasons. So they ended up having, I think it was 10 or so numbers out of the second group of 10,000 numbers used. So you had a lot of stuff going to intercept. One thing about the number 3 crossbar, if it cannot complete a call to a line equipment, then it completes it to an intercept trunk, which had a 7A intercept announcer on it. These are the multi-frequency receivers that are wired to the incoming registers. I have 4 incoming registers in the office, and there are 6 multi-freq receivers here. One of these is not wired to anything. The other multi-frequency receiver is wired to the master test frame. So this office had 100% of the trunks were either capable of MF or DP, which was unusual. In the number 5 crossbar, you would have trunk groups that were only MF or only dial pulse. But again, due to the size of the office, they made a lot of this stuff combination, so you could either have MF or DP. Number 5 crossbar has the ability for revertive pulsing, and the number 3 did not have that ever incorporated into it. Revertive pulsing was what was used to talk to panel switching systems, and when the number 3 crossbar was made, there may have only been 2 or 3 panel systems left in operation in the United States, so they did not make any provisions to talk to a panel switch. We're zoomed into what is called a sender. Whenever a call is made that is external to the crossbar switching system, the marker determines through a route relay the trunk group and also the type of trunk that it's being connected to, such as a MF trunk or a dial pulse trunk. When you call from a crossbar switch into a step-by-step, you need to have what is called a dial pulse trunk, because the step-by-step does not have the ability to deal with multi-frequency. If you was to make a 1+ call to outside the crossbar, your call would be completed through a tandem switch, and this office would send the number you dialed and the number you're calling from, both in multi-frequency. So these senders can do one of two functions, actually three. They can send on an EAS basis an MF call, a dial pulse call, or a camera call. If you was to dial 911 for an example, it would land on an MF trunk and would then send the number that you're calling from, but it would not dial 911. You would have a dedicated trunk. Of course, it could send a number if needed to in that particular case. If you dial 0 and a 10-digit phone number, of course the originating register receives all of the digits. At the end of the 7th or 10th digit, the marker comes in, looks in a route relay, which is 20 route relays within the number 3 crossbar system, determines that it needs to be set up on a trunk, which is an operator trunk, to the TSPS office, and then it would send the number you dialed as well as the number you're calling from. That would be done in multi-frequency. The call I just made was sent out into the step-by-step as dial pulse. You have pulse generators that is effectively creating the same type of a pulse that a rotary dial telephone would send. During that entire sequence of operation, it sent 4 digits into the step-by-step system. I was fortunate enough to acquire some recorded announcement systems that were installed in number 1 and 1A ESS offices. The last generation of recorded announcement that Western Electric made for the 1A machine was the 13A. This is a multi-channel recorded announcement. This message is recorded on what was called bubble memory, which was an early solid-state type of memory. So as long as the 13A was powered up, and in a central office it would always be powered up, then whatever message on the card would be played. Of course, when you removed the power, you lost the message on the card. They did have a battery on the card that you could take the card out and plug another one in or swap them around within the channels and not lose the message, but it was a short-term solution to a long-term problem of taking power off of it. The next system here is a 6A. This is a 6-channel drum. The drum rotates 24 hours a day, 7 days a week, and depending on the channel needed or the announcement needed, the ESS had banks and banks of trunks, and through a amplifier distribution bridge you would have maybe 10 trunks saying the number you reached has been changed or disconnected. Here we have 6 different channels, so I don't know what is on that. I have not actually powered it up to listen to the channels, but whatever was on it when it was installed and working is still there. I do intend on actually powering this up someday and using it, because I think it's kind of neat to have. The 13A is quite an expensive device to run because it's not power efficient. It's some of the early solid-state technology that was, kind of a pig on the electric bill, in my opinion. This is the original ring and tone plant that was built with number 3 crossbar. This system, it produces precise busy, precise dial tone, and precise ringback tone. The same as you would find in today's modern switching systems. This is using solid-state technology to drive relays. With this particular ringing and tone plant in the idling mode draws 11 amps by itself. Because I'm paying the electric bill to run this thing, this was to me an expense that could be done away with. So I electrically replaced this with relays operating off of my Western Electric step-by-step ring and tone plant. I do intend on providing one small tone source to provide a different busy and busy tone and dial tone to the crossbar, so it won't be the same as the step-by-step. But this system was used in what was called a 5A crossbar as well as the number 3 crossbar system. And it was one of the last ring and tone plants that Western Electric designed. Interesting enough is this is designed by Western but actually built by Lorraine. This is the Western Electric CDM that was built with the number 3 crossbar. It's a miniature cosmic frame, the same similar design as a regular cosmic frame, except the blocks in a normal cosmic frame would be yellow or blue. These are heat coils for each of the subscriber lines, so there's 100 potential phone lines here going off to the businesses or community, residential people in the community. So you would run a cross connect between the line equipment and the protector frame, and then also you had trunks. You could go between the trunk and the protector as well. This is unique, that this is the smallest cosmic frame I've ever seen in my lifetime, and it was a neat idea. It kept all of the jumpers very short and very neat, and of course this was standard with the number 3.